Okay, so what we're going to do here is quickly factor some quadratic functions and then use our factorization to find the x-intercepts of the function. So one thing that we want to know ahead of time is the zero product property. And the zero product property basically says if you have two things that are multiplied to equal 0, there's only one way for that to be true. Either A has to be 0 or B has to be 0, right? Otherwise, there's really no way to get 0. We can't multiply 2 by 1/2 and get 0. We can't multiply 2 by -5 and get 0. If we're multiplying, then one of these things has to be 0. And this is one of the most important properties in algebra because it helps us solve equations. So an example of how that might work is if you've got, 2x times x minus 5 times 3x plus 2, and all of these things are multiplied to equal 0. So we've got something multiplied by another thing, multiplied by another thing. If we want to find the solutions to this equation, we can basically say, well, since I've got things that are multiplied to be equal to 0, then either that has to equal 0, or that has to equal 0, or that has to equal 0, and those will give me my solutions. So this means that either 2x equals 0, that's my a in this case, or x minus 5 equals 0, that would be like b in this case, or maybe even a c here, 3x plus 2 equals 0. So a lot of times we can just see the x values at this point, but what we're actually doing is setting each one of these things equal to 0. And why that's helpful is these are very simple linear equations that require 1 or 2 steps to solve, whereas this, if we multiplied it all out, would be a third degree, right? X times x times x. So once you have 2x equals 0, you can divide by 2 and get x equals 0. When you have x minus 5 equals 0, you can add 5, and that means that x equals 5. And here, 2 steps, we'll subtract 2 and then divide by 3. So we should get x equals -2/3. Okay? If we wanted to check to make sure that this works, we could plug in 0. Well, if I plug in 0, I would get 2 times 0 times 0 minus 5 times 3 times 0 plus 2 equals 0. Does it? Well, that's 0 times -5 times 2. Is that 0? Certainly 0 times -10 is 0, so 0 equals 0. Yes, that works. If I plug in 5, I'm going to get -10 times 5 minus 5 times 15 plus 2 equals 0. Does it? -10 times 0 times 17 equals 0. Certainly 0 equals 0, again, because I'm multiplying by 0. Plugging in -2/3, that would work as well. I'd get 2 times -2/3, which is some number, times -2/3 minus 5, times, plugging this in here, 3 times -2/3 is -2. -2 plus 2 equals 0. Does it? Some number times 0, because that's going to be 0, equals 0, 0 equals 0. Yes, so clearly this zero product property works here. And that's what we're going to use once we've factored our quadratic expressions to to find the x-intercept. So let's look at a few examples here now that we are factoring. Okay, so we had y equals x squared minus 8x minus 9. So this is a nice quadratic because it has a equal to 1, right? We've got a coefficient of 1. So anytime that's the case and you want to try and factor, you're simply looking for two numbers that multiply to -9 and add to -8. So multiply to -9, well, that could be -3 and 3, but that doesn't add to -8. Or it could be -9 and 1, and that does add to -8. So basically that tells us that this factors to y equals x minus 9 times x plus 1. Okay, we could check by distributing to make sure that this works. And we would get x minus 9 times x plus 1. Distributing, we get x squared plus x minus 9x minus 9, which is x squared minus 8x minus 9. Again, you can see the negative 9 and the 1 multiplying to get negative 9, and the negative 9 and the 1 adding to get negative 8. So that definitely works. Now, if we want to find the x-intercepts, we want y to be 0, because that's the value of y along the x-axis. So we set y to 0, and now we say, we've got two things multiplied to be 0. That sounds like the zero product property. We can say 0 equals x minus 9, or 0 equals x plus 1. Again, don't forget that when you have two things multiplied to be 0, then either a has to be 0 or b has to be 0. And so when we're solving this equation, we set them both equal to 0. Now, adding 9, we should get 9 equals x and negative 1 equals x. So sometimes we try and memorize, oh, it's the opposite, but then we get confused when we're factoring, and maybe we factor it in an opposite way. So it's always good to take that step and say, let me set this equal to 0, let me set this equal to 0, and then I know, oh, adding 9, I get 9, subtracting 1, I get negative 1. So this is what I like to call nice quadratics, right? This is a nice girl right here because it's got a coefficient of 1. Let's look at one other. So what if we had y equals, let's say, x squared plus 6x plus 8. Now I'm looking for two numbers that multiply to 8, add to 6. Ooh, that sounds like 4 times 2 and 4 plus 2. So y is equal to x plus 4 times x plus 2. That's the factorization. If I want to find the x-intercepts, 0 equals x plus 4 times x plus 2. Zero product property, either x plus 4 has to equal 0 or x plus 2 has to equal 0, in which case x equals negative 4 or x equals negative 2, which happen to be the opposites of those factors. So these are sort of the nicest quadratics. Okay, let's look at a slightly different kind of factoring here. Let's try y is equal to negative 3x squared minus 6x plus 9. So what is different about this quadratic? Well, a does not equal 1. So it's not as easy as some of the other ones because we've got that negative 3 out front. So if that's the case, the first thing you want to check is there a greatest common factor that I can factor out? So in this case, everything is divisible by 3, and I like to get these negatives out of here because then I can hopefully have a nice quadratic. So what I'm going to do is first factor out the negative 3. That would be negative 3, and what's left is x squared plus 2x minus 3. That would be negative 3x squared minus 6x plus 9, so that's correct. Now, hopefully what's left is a nice quadratic, and that it is because I've got a coefficient of 1 here now. I'm just going to leave the negative 3 out front and see if I can find two numbers that multiply to negative 3 and add to 2. I can. It's x plus 3 and x minus 1. And so this is my factorization. Now, if I want to find the x-intercepts, I make y 0. I get negative 3 times x plus 3 times x minus 1. And again, I should use the zero product property. So what does the zero product property say? It says if I have multiple things multiplied to equal 0, then each one of them is going to be set equal to 0 to find my possible solutions. So that means either 0 equals negative 3, or 0 equals x plus 3, or 0 equals x minus 1. Well, clearly 0 does not equal negative 3, so this does not give me a solution. But if 0 equals x plus 3, then negative 3 can equal x. And if 0 equals x minus 1, then 1 can equal x. So my x-intercepts are just x equals negative 3 and x equals 1, or I could write them as negative 3 comma 0 and 1 comma 0, which is a nice way to write your x-intercepts. So in this case, we had a coefficient that was not 1, so we factored out a GCF first. Another type of problem that's similar that requires a little bit of thinking would be something like y equals 6x squared minus 12x. This is a quadratic expression as well, right? Because you have the x squared, but there's no c value, there's no constant, which actually is kind of nice. And so it's not going to factor like the nice quadratics, but it's actually pretty straightforward. Again, a does not equal 1, so we want to look for a GCF. Okay, there's no c value. If there's no c value, then certainly there's going to be something in common here because they both have an x. So look for a number and a variable that they have in common. Here we'd get y equals 6x times x minus 2, right? 6x times x is 6x squared, and 6x times negative 2 is negative 12x. Now again, zero product property if you want to find your x-intercepts. So if 0 equals 6x times x minus 2, then either 6x equals 0 or x minus 2 equals 0. Divide by 6, x equals 0. Add 2, x equals 2. So your x-intercepts, 0, 0, and 2, 0. Now hopefully at this point we can start to just see the pattern of, oh, if everything has an x, then certainly if I plug in 0, I'm going to get out 0. So I should already expect that 0, 0, and that 2, 0. Okay, so we have seen nice quadratics. We've seen quadratics that allow us to factor out a greatest common factor first. Now let's look at the last type of quadratic, which has some slightly different characteristics. Let's look at y equals 2x squared minus 5x minus 3. So here we notice that a does not equal 1. And so we look for a GCF. Is there a greatest common factor? Well, they don't all have x. 2, negative 5, and negative 3, all they have in common is 1. So there's always a greatest common factor, but in this case it's 1, which really doesn't help us out, because if we factor it out, we'll get the same thing. So that's kind of silly. So in this case, you might want to think, let me try factor by grouping. So factor by grouping works like this. You multiply a by c, a times c, to get negative 6. And again, this is helping us deal with this coefficient that's not 1. And now we follow the same process. Two numbers that multiply to negative 6 and add to negative 5. Well, that would be negative 6 and 1. So then we rewrite our quadratic as y equals 2x squared minus 6x plus x minus 3. Again, that negative 5x is being written as minus 6x plus x, which came from our factorization of a times c. Now we factor by grouping. So we are going to essentially group the first two and group the second two and pull a greatest common factor out of each. So what's the greatest common factor of 2x squared minus 6x? It is 2x, and what's left is x minus 3. What is the greatest common factor of x minus 3? It's 1, and what's left is x minus 3. And now we can write it as y equals 2x plus 1 times x minus 3. Again, because if 2x times x plus minus 3 and 1 times x minus 3, that's what we would get if we distributed this. We'd get 2x times x minus 3 and 1 times x minus 3. Now here's again where if we want to find the x-intercepts, we want to use the zero product property. And so if it's two things multiplied to equal 0, then either 2x plus 1 equals 0 or x minus 3 equals 0. In this case, we're going to subtract 1 and divide by 2. And in this case, we're going to add 3. So our x-intercepts, negative 1/2 and 3, we could write as negative 1/2, 0, and 3, 0. So that's factor by grouping. and using the zero product property. Let's look at one more example of factor by grouping. We'll just look at that over here. So let's say that we had y equals negative 2x squared minus 7x plus 15. So again, there's no greatest common factor here, and a does not equal 1. So our a does not equal 1. There's no GCF. So we'll try factor by grouping. So we'll find a times c. In this case, that's negative 30. Now we'll look for two numbers that multiply to negative 30 and add to negative 7. Well, that's negative 10 and 3. So we'll rewrite our quadratic as y equals negative 2x squared minus 10x plus 3x plus 15. Then we'll group the first two, group the second two, and pull out a GCF. GCF of negative 2x squared minus 10x is negative 2x, and what's left is x plus 5. The greatest common factor of 3x plus 15 is 3, and what's left is x plus 5. These need to be the same thing in order for this to work. And now we can write it as y equals negative 2x plus 3 times x plus 5. And now that we factored it, if we want to find the x-intercepts, we can say 0 is equal to negative 2x plus 3 times x plus 5, and again use the zero product property. So either negative 2x plus 3 equals 0, or x plus 5 equals 0. Negative 2x equals negative 3, or x equals 3/2, and here x equals negative 5. So that's given me my two x-intercepts. So as a quick summary of everything we want to know, you can have a nice quadratic like x squared plus 7x plus 12. You can look for a GCF like 3x squared plus 9x plus 12. You can factor by grouping, like something like 2x squared plus 7x minus 15. These are really your choices for factoring quadratics. And let's not forget the zero product property, which allows you to use factoring to solve equations. If 0 equals a times b times c even, then either a equals 0 or b equals 0 or c equals 0. Highly important property.